Greetings, Sharks. My name is Addison Hardy, and along with my colleagues Anuj Nair and Anish Mariella, we are here to present you with our reservation management application. So, for our overall pitch, our project is a reservation application for a restaurant with a client server system that will take reservations from customers and handle seats, times, bookings, and cancellations on the customer side. And as for the management side, staff will be able to manage reservation data and restaurant status, as well as bookings, such as seating arrangements, special events, locked out in specific sections, as well as managing appointments in general. The goal of the program is to improve the overall experience in restaurant booking management with a system based on reliability and efficiency. Our goal overall is to just streamline the reservation management process for both the customer and the management side. To begin, for our project, we created a flowchart of the client side of our program to see what we wanted our users' application to look like. So, as the app is started, the login graphical user interface is opened, and users are either prompted to create an account or log in. Upon logging in with their either original account or newly verified account, their access is granted and the client GUI is opened. They are given three tabs of options to either book a reservation, view their appointments or reservations, or manage their accounts. Upon booking a reservation, a seating chart is available where they are able to see the availability of different seats at different dates and different times. For managing appointments, they are allowed to put in their appointment ID or user ID to see what appointments they have, and then either cancel or reschedule those appointments. And then account is just managing their account. Through these different applications, the client GUI or GUI will send a request to the server, and upon verification of the request by the server that it is a valid request, they will do actions. The server will commit an action such as deleting the reservation, confirming the reservation, or showing the user their current reservations. Finally, the user will either continue with another form of the application, such as like booking a reservation and then viewing it, and or logging out. So for our client program and server, the client is the main communication between the user information and the server. So every time a user commits an act, it's within the client graphical user interface or the main, and those are connected to the server using sockets upon login. And so all of those responses to the client GUI are sent to the server. So the server and actions will accept client connections, process requests, and execute the server classes to return the results based on what the user inputs in the client.
Security and user management are critical components of any reservation system, and we've built a comprehensive authentication layer. The login manager and login manager actions form the core of our system's security system. The login manager stores all the user credentials securely and validates users during the login process. This is our first line of defense against unauthorized access. No one can make or view reservations without proper authentication. Login system and the login system actions work as an additional layer that coordinates between the user interface and the database. When someone tries to log in, the login system verifies their credentials with the login manager before granting access. The user class and the user actions represent individual accounts in our system. Each user object contains their username, encrypted password, and their role designation. Whether they're a customer or an administrator, this role-based access control is crucial because it determines what features each user can access. All three components, login manager, login system, and user, work together seamlessly with our database to ensure that every login is verified, every password is checked, and every user only sees what they're authorized to see. We've included comprehensive test cases for each of these classes to ensure that our security is airtight and functions correctly under all conditions. The heart of our system is the reservation and appointment management, which we've implemented through three interconnected classes. Appointment and appointment actions handle the core booking data. Each appointment object stores an auto-generated ID, the date and the time of the reservation, and the username of who made it. We've designed appointments to be immutable once created, preventing accidental modifications that could cause confusion. Reservation and reservation actions extend this concept with additional details like party size and special requests. Reservations link directly to specific tables and time slots, creating the complete picture of the restaurant's booking status. The seat class and seat actions represent the physical layout of the restaurant. Each seat object knows its table number, section, and current availability status. This is crucial for our real-time seating chart feature. When a customer books a table, the seat status immediately updates to occupied, and all other users see this change instantly. These three classes work together to create a comprehensive booking system. When a customer makes a reservation, an appointment is created, and a reservation is recorded with all the details. as well as the seat is marked as unavailable. This interconnected design ensures data consistency and prevents double booking problem that plagues manual reservation systems. Persistence is critical. If the server crashes or restarts, we can't lose all the reservation data. That's where our database layer comes in. Database.java serves as the central storage hub for our entire application. It maintains in-memory collections of all users, appointments, reservations, and seat configurations. But more importantly, it provides thread-safe methods for accessing and modifying this data. Since multiple clients connect simultaneously, we've implemented synchronization to prevent race conditions where two people might try to book the same table at the same exact time. Data saver and data saver actions handle the actual persistence to disk. These classes use Java serialization to save our objects to files users.dat, appointments.dat, reservations.dat, and seats.dat. Each time data changes, it's immediately written to disk. This means even if the server crashes, all reservation data is preserved and automatically loaded when the server restarts. We've included extensive test cases for the database layer, including concurrency tests that simulate multiple clients accessing data simultaneously. These tests verify that our synchronization works correctly and that no data corruption occurs under heavy load. This robust database design gives restaurant owners peace of mind that their valuable customers and reservation data is always safe and available. Let's talk about the user experience from the customer's perspective. When a customer opens our application, they're greeted with a clean, professional interface that immediately prompts them to either create an account or log in. We've implemented this authentication requirement to keep reservation data secure, to enable personalized features like viewing your own booking history, etc. Once logged in, customers see a visual seating chart, an actual layout of the restaurant with 30 tables arranged in a 5 by 6 grid. Actual available tables are displayed in green, while occupied tables are displayed in red. This visual approach is far more intuitive than text-based systems that lets customers see exactly what's available at a glance. To book a table, customers simply click on an available green table. A dialog appears with easy-to-use drop-down menus for selecting the date and time. No more typing dates incorrectly. We've also implemented smart validation, where customers can't book a table more than 7 days in advance, and they can't select dates in the past. The system automatically generates a unique appointment ID so customers don't have to worry about choosing one. All input is validated before being sent to the server. If something's wrong, like selecting an invalid date, the system immediately alerts the user with a clear error message. Once validated, the request goes to the server and the database is updated in real time. This means every other user immediately sees that the table is no longer available, completely eliminating double booking. The server is where all the magic happens behind the scenes. Let me walk you through how it works. When we start the server by calling the run method, it begins listening on port 8080 for incoming client connections. This is like opening the restaurant's doors. The server is now ready to serve customers. Here's the crucial part. When a client connects, the server doesn't handle that client directly on the main thread. Instead, it creates a brand new thread specifically for that client. This multi-threading design is essential because it allows our system to handle dozens of simultaneous users. While one customer is browsing available tables, another can be completing their booking, and a third can be viewing their appointments, all at the same time. No waiting or performance degradation. Each client thread reads incoming requests, processes them, and sends back responses. For example, if a client sends a login request with their username and password, the server validates those credentials against the database and responds with either success or failure. If a client requests to create an appointment, the server validates the data, checks if that table is available at that time slot, creates the appointment in the database, and confirms the booking. Security is enforced on the server side. The login system verifies every user before allowing them to access any features. Role-based permissions are checked. For instance, only administrators can view all system reservations, while regular customers can only see their own. The server constantly interacts with our database class to save and retrieve information. Every booking, every user account, every seat status, it all flows through the server to the database. This centralized design ensures data consistency and makes the system much easier to maintain and debug. Finally, comprehensive error handling ensures that the server never crashes. If a client sends malformed data or a network error occurs, the server catches the exception, logs it for debugging, and continues serving other clients without interruption.
So to start off, we're going to go and look at our user accounts. So first, we're going to create an account. We're going to name it John123, and then we'll put the password as 1234. Create account. Account created. You can now log in. And now I'm going to do John123. And then just to show the password protected login, I'll just do a login straight up. Doesn't work. Random anything. Valid credentials, and I'll do 1234, and I'll be able to log in. So now what I want to show is show the selected date for the reservation. So for table 1, we have the menu. It shows the date, the 8th for today. You could change that to the 9th, to the 10th. We'll change it to the 10th for now. The time, the hours are from 9 to 9, so we go all the way from 9 to 9 p.m. We'll choose 16, which is 4 p.m., and then we'll do a party size. Every table is max 4, so we have 1 to 4, so we'll do 4. Appointment ID 1003. So we'll click OK, set appointment 1003. We'll go to my appointments, we'll put in 1003, and you'll be able to show the appointment details right then and there. Also, if you need to cancel the appointment, we have cancel this appointment right here. Done. Appointment has been canceled. And then once we go back to book table, it shows here, but if you log out, log right back in, perfect. Table 1 is now available. And to show that everything is saved, I'll create, let's see, table 2. And first I want to show how it only goes up to 7 days. So it's the 8th, we'll put the 16th. 12, all right, let's see, can book more than 7 days in advance, that is perfect. So we'll go back to table 3, 12, 8, we'll do 9 o'clock, do 2 people, 1004, all right, perfect, we'll do that. Booking for John, and then we will now move to the management side of the project, the demo, and then for the management, the username is admin and the password is admin123. Log in, and you see right here, there's an appointment right here, seating layout right here. If you need to lock out a table, if it's any like special events, you do status, you do lock table right here, meaning table has been locked. Unlock table right there for special occasions, parties like that. Set hours of operations, we have 9 a.m. to 9 p.m. And for the seating layout is right here. It's the same every table. There's 30 tables, every table seats 4, and then it'll show the availability and just be user-friendly for the admins and the clients. And that is all for this demo. I've shown everything that it's done and everything that you have required from us.
How is the user experienced? We put a lot of effort into editing our graphical user interface for our user experience to make the process easy and manageable, such as with the 2 different tabs at the beginning to either create an account for the user or log in with an existing one. How does our program handle multiple clients accessing at the same time? So our program allows users to connect, and each time a client or a user is connected to our server, it creates a new thread in order to allow different users to access different requests at the same time. And we have ensured that one client's request will not inhibit or infringe on another client's, no matter how heavy or how in-depth their request is. Our target users as of right now are small to medium-sized restaurants. As of right now, our program is able to handle multiple users, a couple of dozens, but not a mass amount of users, such as with a large-scale restaurant, though we plan to have that in the future. How do restaurants benefit from the system? The ability of restaurants to take reservations and handle the reservation process without a physical phone call or a person overall just streamlines the management of the reservation process and allows users to handle the reservations on their own, allowing management and staff at the restaurant to focus on taking or seating more people in the restaurant, overall increasing profit, as opposed to taking reservations on the phone or canceling, all of the above. And with the ability of users to immediately cancel a reservation through our product, that will open other opportunities for people to, again, update the availability of the seat based on a cancellation, and then a new user will be able to book that reservation. We have ensured reliability with our system, again, by allowing different users to access it at the same time with our different threads. But we also have an abundance of test cases and JUnit tests to ensure that every part of our program runs correctly. And overall, our system solves the problem of just delayed reservation management as well as double bookings. And we have created this program to just streamline the process for both management and users to create an overall better experience. Thank you.